A rocket is fired vertically with a speed of 5 kilometer per second from the Earth's surface. How far from the Earth does the rocket go before returning to the Earth? Given mass of Earth to be 6 into 10 raised to the power 24 kg and mean radius of Earth to be 6.4 into 10 raised to the power 6 meter, and gravitational constant G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So if I assume Earth to be roughly spherical body and this R is the mean radius of Earth. So a rocket is fired, suppose this is rocket. This rocket is fired with a speed of V is equal to 5 kilometer per second, or V is equal to 5 into 10 raised to the 3 meter per second. So we have to calculate when it is projected with this much speed, what is the maximum height that the rocket will reach, and then it will come back to the ground. So let me suppose h is the maximum height attained by the rocket. So applying energy conservation, that is total energy at surface is equal to total energy at the highest point h. This h is the distance from the surface. So total energy is at surface is gravitational potential energy, which is G mass of Earth into mass of rocket by R. Here kinetic energy is half m v squared, and the total energy at the height h from the surface is equal to minus G mass of Earth into another mass divided by R plus h. So, and kinetic energy at this point is zero, because at the highest point the speed or the velocity of the particle rocket will be zero. So this implies on rearranging half m v square comes out to be g m e small m divided by 1 by r minus 1 by r plus h. So this implies this m gets cancelled. Half v square by gm is equal to r by r plus h, r plus h minus r. Now this is further equal to v square by 2g into mass of Earth is equal to h by r divided by r plus h. Now we just need to rearrange and solve the equation. This will be v square r square plus v square capital R h, which is equal to 2 times g to mass of Earth into h. And this is further equal to h times 2gme minus v square r is equal to v square r square. This simply comes when we take this factor here and take out h common from both the terms, and this remaining factor remains in the parentheses. So this implies h is equal to v square over r square by 2 times gme minus v square This is r square minus v square r square. This is v square r. Also this v square. Now just we need to substitute the values. V is 5 to 10 raised to 3 whole square into 6.4 into 10 raised to 6 whole square. Divide by 2 times value of gravitational constant, which is 6.67 into 10 raised to minus 11 into mass of Earth, which is 6.0 into 10 raised to 24 kg, minus v square, which is 5 into 10 raised to 3 whole square. There is scarcity of space, so I'm writing this down, that is r here. So r is equal to 6.4 into 10 raised to 6 meter. So solving this bulky term, h comes out to be 1.6 into 10 raised to 6 meter. So the total distance of the rocket at this point from the center of Earth will be r plus h, which is equal to 1.6 into 10 raised to 6 plus 6.4 into 10 raised to 6, which comes out to be 8 into 10 raised to 6 meter. This is the distance from the center of Earth. From center of Earth. And this is the required answer.